everybody, we're going to be going over Kelvin, Celsius, and Fahrenheit conversions. So these are going to be the formulas that you want to have in mind. I think that on the slideshows he showed you a weird number of like 1.8, but on the reference table that you guys got on the test, it showed you these formulas. These are also the formulas for Kelvin. Now we don't say degrees Kelvin, it's just Kelvin. So let's get started with an example. It's going to be more of a quicker video just because there's not too much to go off of. We really just have plug-in conversions with either Kelvin, Celsius, or Fahrenheit. But let's try first going from 10 degrees Celsius to Kelvin. So if we want to go from Celsius to Kelvin, let's see how we want to do this. So we want to say, oh, look at there, Kelvin will equal some degree in Celsius plus 273. So we would do 10 degrees Celsius plus 273 equal to 283. I'm sorry if my voice is very quiet. It is 100% 11 in the morning. Definitely not. But that's all it is. Oh wait, hold on, whoops. My mistake, 0.15. And it would be 283.15 Kelvin. And there it is. That's all it is. Now, what if we want to convert from, what did I do there? That was supposed to be Celsius. Now, what if we want to do from Celsius to Fahrenheit? Well, Celsius to Fahrenheit, we have Fahrenheit equals 9/5 Celsius plus 32. We can write out 9/5. The Celsius number that we have plus 32 is equal to 40 degrees Fahrenheit. That's it. Just a plug-in conversion. Now let's move on to density. So again, I don't know how many questions he would give you on density, but it's good to understand it. So density, this is the formula that you should understand for density. This is just the written out when you're only given 2, and then you would have to figure out the mass. Let's see an example of that. So we're trying to figure out the mass of a 49.6 milliliter sample of liquid of a liquid density, and they give us the density here. So if we already know the density and the volume, we can plug it in. Well, let's do 0.85 grams per mole is equal to, well, the formula says volume is at the bottom, so we'll put 49.5, is it 0.5? 0.6. And since we don't know the mass yet, let's put an x. Now we can rearrange this equation by following the format at the top. Mass, or we can also put as x equals volume let's write it out. It would be multiplying these two, you should get a number of 42 milliliters. Now, this is actually a separate problem, but I drew this nice cube. So what if they gave us centimeters and the mass here? So we don't know the density, but we can figure out the volume using this. It's just like times width times height, which for a cube, it'll be all the same. So for density, equal to, I believe they said 12 grams over, and oops, 488 cubic, not cubic, centimeters cubed. So we can put this, and when we solve the answer, we'll get 1.50 grams over centimeters cubed. I will 100% up the volume on this video because I am talking really quietly. And what if they gave us a bigger cube? All they did was just increase the size of the cube. Well, we already figured out the density. They tell us to find the mass. So what do we have? What do we have left here? So it's that over v. We have our density of 1.550. I got this number here because 3 times 3, so if it's 3 times 3 times 3, we're going to get here 9, then we got to multiply another 3 here. Now we get 27. Wait, that worked, right? Yeah, they did. So it's the same scenario we had up here. All we have to do is just multiply the two numbers, and we will get 40.5 grams. Now, you also have to remember your sig figs, so let's double check. We have 3 here, we have 3 here. We multiply it, so we take the lowest number, which is still 3 sig figs. Now to quickly go over Boyles' law. So Boyles' law is let me write it out. This is the formula of Boyle's law. So it's going to be the initial pressure and the initial volume is equal to the final pressure, the final volume. You'll get a scenario like, I didn't copy and paste it. Okay. Ignore what you guys see here. Ignore it. I said ignore it. So you might get something like here. You're given 2.00 liters of gas at 740, I believe that's like millimeters of mercury or something. That's our pressure, and we're set that what is the volume at 760, I'm not going to try to pronounce it, millimeters of mercury, something. Boyle's law works like this. These are two initial, did I spell initial right? Initial, hopefully. These are two initial values, and they tell us, okay, later on, what would our volume be at a pressure of this? So this is how we'll do Boyle's law. So we'll take the pressure multiply it by the volume, the initial volume, set it equal to the final volume and the final pressure, which right now we only have the final pressure. So we can put X here. On this side, we'll get then we would divide by 760 because we would get, let me rewrite it actually, 7 equal to 7. Now we want to divide and get X alone. So we'll get about 1.947. Now we gotta check sig figs. So this would also round up to, I believe we can say it rounds up to 1.95. I believe this was one of the questions. I might have actually slipped up here. Let me actually erase that. Let's check sig figs. It is very late, so I'm sorry. So we have 4, 3, and then 2. We divide here, and this still has 2, 3, and that tells us that we have to go with the lowest sig figs. So our answer should be, I hope this is the answer, but it should be 1.9. Is that 2 sig figs? Yeah. Yeah, it should be 2 sig figs. Okay. Now I don't have any more than this just because once I get the practice exams, then we'll see what other kind of scenarios that we'll have. There might be a scenario where the pressure, you might have this maybe in like millimeters of mercury, and then you'll see here ATM. You can't have it like that. One of these has to convert. You'll eventually have a scenario like that. And let me just go through everything. Is everything good? I think that's everything. Thank you, everybody.